Oh, I need to shrink it now. There, that's good. All right. Okay, least common multiple, 2 or more numbers, is the smallest number that is a multiple of each of the given numbers. Okay, least common multiple. Okay, remember, least means the smallest. Common, what they all have in common. Okay? Multiple, guys, is completely different than factors. Factors are what numbers go into it. Least common multiples are, remember, multiples, they get bigger. Like 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5. You know what I'm saying? They get bigger. We're multiplying. Okay? The word multiple comes from multiplying. So least common multiple of 2 or more numbers is the smallest number that is a multiple of each of the given numbers. Okay? I tell people that this word smallest is what confuses students. It should say the first. In fact, I'm going to write that. 2 or more numbers is the first number that is a common, I like that a lot better than the actual definition, a common multiple of each. So I wouldn't say the smallest, because then you're going to start thinking it's a factor. You know, it could be like the least common multiple could be 643. Well, that's not a small number. You know, you think small, you think a small number. So it should read the first number that is a common multiple of each of the given numbers. All right. Does everyone have this? Yes. Good job. And Emily, just so you know, it's been a Monday. I'm going to have to keep hitting pause, I'm sure. Hopefully not. Find the least common multiple using exponential form. We have a sub for Miss Erica, and she is having technology issues. So I have to keep leaving, talking to Miss Drexler. All right. Number 1. We're going to find the LCM, wake up, Cecilia. Okay, good. We're going to find the least common multiple using exponential form. Exponential form. What word pops out in exponential form? Exponent. So we know we're using exponents. Step 1, you're going to write the prime factorization of each number. Same as GCF, basically the factor tree. So basically, the first thing to do is do a factor tree. Again, just like greatest common factor. And then step 2. Write, just like we have, well, no, we didn't write the greatest common factor in exponential form. Remember, we listed them out with the multiplication, and we circled the pairs, right? Well, this time we're going to write in exponential form. If needed. Like if you can. Okay, now here, step 3 is the hairy one. Are y'all ready? Y'all have step 2 down? Okay, I'll wait. You got it down, Joanne? Okay, the hairy one. Step 3. Find the product. What does product mean?
Multiplying.
That's right.
The answer.
The multiplying. It's, yeah, I'm going to put a little parentheses with the dot. That means multiplying. Of all the prime factors that are represented. Now here's the crazy part. Look, I'm putting 2 stars here. Use the highest powers. You don't want to use low powers, right? You want to use the highest powers. Look, exclamation marks and more stars.
Over 9,000.
Shh. What does it mean, powers?
Exponents.
Very good. Powers mean exponents. So we're going to be using the highest powers. Joanne, you almost got it? You got it? Okay, good. All right, so real quickly, just to recap, least common multiple. Let's say I have 6 and 9. Tell me all the multiples of 6 with.
1.
Nope. These are multiples, not factors.
Oh.
Nope, that's a factor.
6.
6 is the first one.
12.
12.
18. 24. 30.
Okay, we can stop there. That's your multiples, guys. This is the most common mistake on quizzes and tests is kids will start giving me factors. You're going to have to study and practice that. Multiples, think of multiply, we're multiplying. 6 times 1, 6 times 2, 6 times 3, 6 times 4, etc. Yeah, that's going to be on y'all to memorize which is which, okay? So what are the multiples of 9? Whoops, what? 9, 18, what? 27, 36, etc. Notice that's the first number that they both have in common. That's the first multiple that they have in common. So your least common multiple is 18. You understand what we're doing today?
Yes.
Okay, But you know that your questions aren't going to be that easy, where you can just list the multiples and figure it out. There's a little bit more to it. Does everyone have this down? All right. So we're going to do an example. We're going to do just lots of examples. We're going to find the least common multiple of 12, 28, and 75. 12, 28, and 75. Step 1 says write the prime factorization of each number, which is your factor tree. So we're going to do a factor tree of all three of those. So Izzy, what two numbers when multiplied give me 12? 6 times 2. Is 6 prime? Izzy? No. Is 2 prime? Yes. So I circle it. If I'm circling it, you're circling it. What two numbers when multiplied give me 6, Izzy? 3 times 2. Is 3 prime? Yes, I circle it. And then we circle 2. I'm going to write my prime factors out later after I do this factor tree. All right, 28. Michael, what two numbers when multiplied give me 28? 2 times 14. Is 2 prime?
Oh, yes.
So I circle it. Is 14 prime?
No.
So I keep going. What two numbers when multiplied give me 14? 7 times 2. Is 7 prime?
Yeah.
I circle it. Is 2 prime?
Yeah.
I circle it. I'll pause to let y'all catch up. All right, what two numbers when multiplied give me 75, Gabby? 5 times what? 5 times 15. Is 5 prime? So I circle it. Is 15 prime? So I keep going. What two numbers give me 15? What? 3 times 5. 3 is prime and 5 is prime. Okay, so down here, I'm going to start writing out my prime factors of each one. Do not skip any steps when taking these notes. You need to do these the same way. All right, so for 12, I have 2, cross out, times 2, cross out, times 3, cross out. So far, are there any questions about where I found these or what I'm doing? Izzy? Cecilia? Whit? Taylor? Any questions?
No, ma'am.
Okay. The next one, I have 2, cross out, times 2, cross out, times 7, cross out. And the last one, I have 3 times 5 times 5, and I've crossed those out. Now, step 2 on your steps that we discussed, it says write the exponential form. So I'm going to do my little arrows here, and I'm going to write these in exponential form. Michaela, how many 2's do I have?
2.
I have 2 2's. So I write it this way, times 3. Any questions about why I did that? Joanne, do you have any questions? Okay, so what would this one be, Joanne? 2 to the power 2, or 2 squared. And times what?
Times 7.
Very good, times 7. And this one would be what, Whit?
3 times 5 to the second power.
Second power. Very good, because I have 2 5's. Does everyone have this down? Because this is where it gets kind of crazy. Okay, so we're going to take all of this and rewrite it, but step 3 says find the product of all the prime factors that are represented. That's the key word. You're finding the product of all the prime factors that are represented. Remember last time with greatest common factor, we just circled the pairs or the ones that they had in common. Remember that? This time it says we're going to find the product of all of them. And it says use the highest power. So let's look at the first one. We have 2 to the second power and 2 to the second power. Is one of them higher than the other? No. So we're over here, we're going to just write one of those. And I'm crossing them both out because we've used it.
Wait, why do we only use one?
We're just using the highest power. They're both the same. So I'm just writing one of those. You'll catch on in just a minute. Okay. Now, we have a 3. The next one is 3. There's no power here. There's no exponent. So, Cecilia, if there's no exponent, what do I pretend is there? A 1. So we have 3 to the 1 and 3 to the 1. Is one of those 3's higher than the other? So then we're just going to write 1, 3 here and cross those out. See, we're going to use every single prime factor, but we're choosing the one with the highest power. If they're the same, then we're just going to choose one of them. All right, the next one is 5 squared. Do I have another 5 somewhere in here? So I'm going to use just 5 squared. And then the last one is 7. So do you see how we're using all of the prime factors, all of them, but we're choosing the ones with the highest power? Do y'all see that? Okay, now we work it out. What is 2 squared? 4. Times 3. What is 5 squared?
25.
Good. I didn't want to hear 10. Times 7. Anyone with the calculator know this? By the way, I will let y'all use calculators today. Well, I'm going to do the math real quick to save on time. But you may use your calculators today. The answer is 2100.
Oh.
The least common multiple for those 3 numbers is 2100. So if we were to go back and start writing all the multiples for 12, all the multiples for 28 and 75, it would take us forever to finally get to one that they had in common, wouldn't it? Yes.
It's 2,100 because 25 times 4 equals 100. 100 times 3 is 300. 300 times
Like
7.
3 times 7 is 21. Very good.
Then you add the 2 zeros.
But look right here. If we had listed the 3 out, the 3 numbers,
I'm doing that.
it would take forever before we got to 2100, wouldn't it?
Yeah.
Right? Therefore, this method is the best.
What if I listed them all?
No, we don't have time for that. Are there any questions? We got more examples. Yes, ma'am.
Do we always do this way instead of listing them all out?
It's probably best. If it's a small number, you can. If it's small numbers, like only 2, especially 2 numbers, and it's small, then it works. But 9 times out of 10, I mean, who would have thought that 12, 28, 75, the first number that they have in common is 2100? That's a lot. All right, let's do another one. Yes, ma'am. Let's do 12, 18, and 24. 12, 18, and 24. Okay. Do you know where they are? Izzy, do you know where they are? There you go. Thank you, Izzy. Okay, well, we've already done 12 up there, right? So let's go ahead and write that down. 6 times 2, circle the 2, and then 3 times 2, circle those. Okay, so we've already done that. Let's do 18 now. You want to do it? All right, Michaela, what two numbers when multiplied give me 18?
9 and 2.
9 times 2. 2 is prime, and we're circling that. Is 9 prime?
No.
No. What two numbers give me 9?
3 and 3.
3 times 3, and those are prime. All right. Good job. Let's see. Taylor, what two numbers when multiplied give me 24?
12 times 2.
12 times 2. Is 12 prime, Taylor?
No.
No, sir. What two numbers give me 12 when multiplied?
6 times 2.
6 times 2. 2's prime. Is 6 prime, Taylor?
No.
No. What two numbers give me 6?
3 times 2.
3 times 2. Perfecto. Okay, now, once you have copied down the factor trees, we're going to write these out. 12, 18, and 24. Now, start off just writing the prime factors. I have 2. Cecilia, you writing this down? Times 2 times 3. Make sure you're writing it all down exactly like I'm doing it. 18. I have 2, cross it out, times 3, cross it out, times 3, cross it out. And then I'll pause and let y'all catch up. 24, Cecilia, because I'm going to pick on you all day, because it's like you got a spotlight around your head. It's where you sat last year. It's so cute. See your face and everything. Okay, so Cecilia, what do I write here?
2 times 2.
Wait, 2, cross it out, times what?
Times 2 times 2.
Times 2, cross it out, times what?
2.
Cross it out, times what? 3, cross it out. Guys, remember, if you're having trouble, I'll ask, show me your notes. If you do not have everything I write down, you'll have to rewatch this video. Now, I'm going to draw my arrows. Joanne, have you caught up? I'll pause and let y'all catch up. If you want, go ahead and write the exponential forms and let's see if y'all got. Okay, Joanne, you're caught up? Okay, so Joanne, what's the exponential form for 12?
2 to the 2nd power.
And?
Times 3.
Perfect, times 3. Let's see, Izzy, what's the exponential form for 18? What?
2.
2. 3 what?
3 to the 2nd power.
3 to the 2nd power. Good. That's what you have to do. And you know what? Let's face it. If you want to say 3 to that little bitty 2 up there on top, I will accept that. It's not grammatically correct in math, but at least you know what you're talking about.
Math isn't grammatically correct.
Exactly. I agree. Gabby, what would the exponential form for this one be? Perfecto.
That's too cute.
All right. Now, this is where it gets crazy. Michael, my first victim. I have a 2 squared. We're going to start the smallest prime number. 2 squared, 2, and a 2 cubed. The rule says use the one with the highest power. Which one is the one with the highest power?
2 to the 3rd power.
So that's the one I'm writing down. 2 to the 3rd power. Not the 2 squared, not the plain old 2. We want the highest power. In our world, who has the highest power?
God.
Very good. God has the highest power. Okay. Now, the next one, we have a bunch of 3s. 3 to the 1st power, 3 to the 2nd power, 3 to the 1st power. Which one do I choose?
3 to the Second power.
That's right. Choose 3 to the second power. We cross all the others out. Yes, ma'am?
Wait. Why didn't you do all of the twos?
Oh, no. Only the highest power. Like God. God's the highest power. We're going to choose the highest power. So we're choosing 2 to the cubed because it was the highest power. And 3 squared, it was the highest power. All right. So what is 2 cubed, Whit?
8.
8 is correct. Because that's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. What is 3 squared, Joanne? Three squared.
7.
Nope. 3 squared is 3 times 3. There you go. No, that's it. It's just, all I ask is for 3 squared. So now, what is 8 times 9, Taylor? 72. So the least common multiple for those 3 numbers is 72.
Not as bad as 2,100.
That's right. Remember, here's 2 stars. Again, only choose the number with the highest exponent, even if the highest exponent is 1. So only choose the number with the highest exponent, even if it's just 1. Yes.
If there's 2 numbers with the same thing, like 2 to the third power, would you only write it once?
Uh-huh. Very good. You only choose, you only choose 1.
I started to repeat what I had just wrote down, so it's going to be with the, choose the number with the highest exponent, even if the highest exponent, even if the highest exponent.
That's kind of how my brain's been working too, Taylor.
Give it up. It's so long.
Mm-hmm. Now I'm about to introduce letters, variables.
Ooh, is
To
it
the
the same
next.
as the GCF?
Yeah, wait. Y'all whine and everything, but if you remember GCF, greatest common factor,
It was
was
easy.
it that bad? No, man, it was not that bad. So really and truly, when you think about it, the letter portion is a little bit easier than actually these numbers. Because you're having to do all this multiplying and stuff and all these factor trees with it, and with letters, you don't have that.
Because they don't have numbers.
That's right. So really, you should look at the opposite. Say, I love the letters. I want to hear y'all say, I love the letters.
Because they're factors.
hate
I
the
love the
No, you do not hate the letters. You love the letters.
math.
Shh.
Or do you?
All right, Joanne, you got it? Okay.
I like math because we don't have to study. Like, I mean,
You do have to study.
You do, but it's not like you're trying to
Bite your
memorize
tongue.
stuff. I mean, you kind of are, but you're not trying to remember words. You're just trying to remember the stuff.
You're supposed to remember facts and formulas and everything.
This is better.
Next,
This is
math
better than studying for like
You got it,
science or
Joanne?
something.
Where are you at?
Even.
Oh, even. Okay.
Math is my favorite.
You're almost there.
Math's my favorite.
Don't erase, just keep writing.
I love math because it's just
So if we start running a little bit at a time, don't worry. The Bible test is only 10 questions. So you'll be done with that soon.
Bible test?
Yes. You'll be done with that soon. So then during Bible, as soon as the test is over, you can get back to work on the math. So I'll be giving you plenty of time.
There's a Bible test today.
Yes, dear.
Yes.
All right, here we go.
I'm gonna study.
Least common multiples of algebraic expressions.
Just numbers.
Okay, this is where we start getting to the crazy letters. So I have 15 x cubed y. All of this is being multiplied. That's 15 times x cubed times y. Remember, if we don't have any operational sign in between, we assume we're multiplying. And then the other one is 21x squared. Just like in GCF, greatest common factors, we are only going to do the factor tree for the numbers. So I'm just doing the factor tree for the numbers. What two numbers, when multiplied, give me 15, Gabby? 3 times 5. And I'm circling those because they are prime.
When writing them like that, do we have to do that in number order?
Oh, no.
Like, so we can write
Yeah, I mean, it's up to you. It makes it easier. Okay, let's see. Michael, what two numbers, when multiplied, give me 21?
7 times 3.
7 times 3. Circle them because they're both prime. Do we need to do a factor tree for the letters?
No.
We didn't in greatest common factor, so we don't have to now. So down here, I'm going to write out the prime factors, just like when we did greatest common factor. So Michaela, what do I write here?
3, cross it out,
Good.
times 5.
Cross it out. Now, here's where, guess what? If you worked ahead, shame on you. When you're doing least common multiple, you don't have to write all the x's out
I know that.
because we're dealing with exponential. So just write x cubed times y. That's it. You don't even have to write all the x's out like you did with greatest common factor. All right, so this one, 21x squared. What do I write, Joanne?
7.
Nope. No, you do smallest first.
Sorry. 3, cross it out.
Good. Times.
7, cross it out.
And what about the letters?
You just do times x.
The second power. Very good. Now, do I need to write any numbers in exponential form?
Yes.
What?
3.
Well, I only have 1 3 in each, so it's just 1 3, right? So there's nothing we have to rewrite here, so I can go ahead and get started. How many, let's start with 3s. How many 3s do I have, Michaela?
2.
No, okay, I have a 3 to the 1 power and 3 to the 1 power. So which one do I choose? Any of them?
Just choose 1.
There you go. Because they're both the same power. Now, do I have any other 5s besides this one? Cecilia, do I? So then I just choose 1 5. And then do I have any other 7s? Izzy, do I have any other 7s? No? So I'm just going to take that one over there. Okay, now look at the x's. I have an x to the second power and x to the third power. Izzy, which one would you choose? Which one? X to the third power. So I cross those out. X to the third power because it's the highest power. And then do I have any other y's? Boys and girls, do I have any other y's? No. So I'm bringing that down there. So 3 times 5 times 7 is 105, and then we just bring down our variables. There is the least common multiple for those two. Any questions? All right, open up your books to page 150, 151. We're going to do 2 examples.
Then Spanish fruit.
And then I'm saying, well, probably then it's going to be Spanish.
No.
And then y'all can work on these when you get back. We're going to start with number 28. Because we've done so many other examples of the other, I'd like to just go ahead and start with this. I'm waiting to see if everyone has their books open. Make sure everyone's got this copy down.
What the heck is that chart on page 151? Looks like Egyptian hieroglyphs. Can't.
All right, 28. The numbers are 36, 54, and 81. We're going to do factor trees. Michaela, what 2 numbers when multiplied give you 36?
3 and 12.
Okay, so 3 times 12. 3 is prime. Is 12 prime?
No.
All right, what 2 numbers give me 12?
6 times 2.
6 times 2. 2's prime. Is 6 prime?
No.
What 2 numbers give me 6?
3 times 3.
What?
Oh, 3 times 2.
Very good. 3 times 2. All right. Right. Make sure you have all that down. Joanne, what 2 numbers when multiplied give me 54? You want to phone a friend? How about 9? How many times is 9 going to 54? Do you know?
Six.
Very good. So 9 times 6 gives us 54. Is 9 prime?
No.
No. What two numbers give me 9 when multiplied?
There's no 3.
Very good. And those are both prime. How about 6? Is 6 prime?
No.
What two numbers give me 6?
3 times 2.
Very good. All right, 81. Gabby. 9 times 9. Are those prime? 3 times 3. And then 3 times 3. Those are prime. Okay, so I'm going to write 36, 54, and 81. So I'm going to write the prime factors here for 36. And I'm going to go smallest to greatest. So I have 2, cross it out, 2, cross it out, 3, cross it out, and then 3. Y'all with me? Okay, for 54, I have 1, 2, then 3, cross it out, 3, cross it out, and 3, cross it out. And then for 81, I have just a bunch of 3s. So I have 1, 2, 3, and then 4.
I love how the 3s slowly take over with each number. It goes 2, 2, 3, 3, 2, 3, 3, 3.
3s are taking over.
The 3s are zombies.
Okay, so what would the exponential be here, Michael, for 36?
2 squared, 3 squared.
Times 3 squared. You gotta have that times there. What would this one be, Michaela, for 54?
2 times 3 to the third power.
To the third power. And this last one, Cecilia, what would it be? 3 to the fourth power. All right, now
3 cubed plus 1.
I have a 2 squared and a 2. Which one do I choose, Izzy? 2 squared. So I'm going to cross those out and I'm writing 2 squared. I have a 3 squared, a 3 cubed, and a 3 to the fourth power. Which one do I choose, Michael?
3 to the fourth power.
3 to the fourth power because it's the largest. So we chose the largest exponent. Now, 2 squared is 4. 3 to the fourth power is 81. If you work it out, that gives you 324 as the least common. I'm trying to save on time. Least common multiple. Any questions?
162 is 81 times 2.
Very good.
Quick math.
Does everyone have this down?
C.
Okay, you got it?
Yes.
All right. Last one.
Wait, what?
This is going to be big ugly.
Oh.
34.
Yay.
I have 16 x to the fifth power, y to the second power, z to the fourth power.
This is awesome.
And then I have 64 x to the third power, y, z. And then the last one is 36 times x to the fifth power times y to the seventh power. Write that down. Now, we only do factor trees on the what, Joanne? Numbers and letters? Just letters or just numbers?
This number.
Very good. We're just doing a factor tree on just the numbers. What two numbers, when multiplied, give me 16? Whit?
4 times 4.
4 times 4. Are those prime?
They're not.
So we're going to continue. What do you get?
2 times 2. And then 2 times 2.
Very good. And make sure you circle your 2's. All right. Make sure you have this down. 64. Taylor, what 2 numbers in multiply? Give me 64.
32 times 2.
32 times 2. 2 is prime. 32 is clearly not. What 2 numbers give me 32?
16 times 2.
16 times 2. 2 is prime. 16 is not. What 2 numbers give me 16?
8 times 2.
8 times 2. 2 is prime. 8 is not. What 2 numbers give me 8?
4 times 2.
4 times 2. 2 is prime. 4 is not. Now what do I have?
2 times 2.
Ooh, look at all those 2's.
So many 2's are gonna die.
Make sure y'all have this down. Gabby, 36. 6 times 6. Those are not prime. So I keep going. What do you get now? 3 times 2. Those are prime. And 3 times 2. Those are prime. Make sure you write those down. And underneath here, I'm going to start writing them out as soon as everyone gets theirs written down. Does everyone have the factor trees written down? Y'all have this written down?
No.
Just go get your math out. Okay, so right here I'm going to write out my prime factors for this. So I have 2, cross it out, times 2, cross it out, times 2, cross it out, times 2. What do I do about the letters? You write them down exactly how they're written, right? Okay, so for this one, I'm going to write times x to the 5th times y to the 2nd times z to the 4th. For this next one, I have a lot of 2's. 2 times 2. Now you see why I say cross them out, because if you don't, you could accidentally mess up. And then I write out my letters, x cubed, y, z. And this last one, it's 2 times 2 times 3 times 3 times x to the 5th, y to the 7th. I'm going to pause until y'all get this. Okay, I gotta keep moving. How many, let's write this in exponential form. The first one, how many 2's are there? There's 4 2's. And then I'm writing my letters out. How many 2's for this next one? 6. So 2 to the 6th. And I'm writing my letters out. How many 2's for the last one? How many 3's? What?
2.
Very good. And I'm writing my letters out. Cecilia, I have a 2 to the 4th power, 2 to the 6th power, and 2 to the 2nd power. Which one are we going to use?
2 to the 6th power.
That's right, 2 to the 6th power. Because it's got the highest power. Do I have any other 3s in here, guys?
No.
So, Michael, which one am I using? 3 to the 2nd power. I'm crossing it out. Now, Joanne, I have x to the 5th power, x to the 3rd power, and x to the 5th power. Which one am I using?
X to the 5th power.
That's right. And there's 2 of them, so you just choose whichever you want, but they all get crossed out. You're using one of those, the one with the highest. Michaela, I have y to the 2nd power, y to the 1 power, and y to the 7th power. Which one am I using?
Y to the 7.
That's right, because it's the highest power. So you can cross all those others out. I have z to the 4th power and z to the 1 power. Emily, which one am I going to use? No, what did you just say? Highest power. Which one would that be? Ignore that. Which one is the highest power?
The X.
The
I don't
z.
know, I wasn't here.
I'm asking because we've been doing this since you've been here. Look, z to the 4th power, z to the 1 power. Which one has the highest power? There you go. So that's the one we're using. That's the one we're using. Good job. So if you multiply the 2 to the 6th power times 3 to the 2nd power, you get 576. And then we just bring down our variables. Very good. So Emily, when doing letters, you just choose the ones with the highest power. See, x to the 5th, x to the 3rd, x to the 5th. Which one's highest? X to the 5th. That's the one we use. Any questions? Once you have, look, I'm going to write down your sign. Well, no, I'll have it written down for you when you get in. Once you have written your notes here, leave everything on your desk and you may go to Spanish.
That is a big number.
Got to turn it in.
Yeah, any homework from last week needs to be turned in.
Well, technically last night for me, we won't talk about that.
Stop on a different paper. No, it won't.
I don't care.
That's when it comes out. Oh, we're supposed to put all of our stuff.
Just Spanish. Just Spanish.
Because Cecilia took the backpack and I got confused.
You don't have to.
There we go.
I finished the entirety of this big book.
Hold on, let me